Alright, let's look at the homework 7.5, problem number 9. Alright, so we want to maximize the volume of a box, one of the whose vertex is sitting on the given plane here. Alright, so let's do that. Alright, so I already drew a picture, so we want to maximize this box here. So the volume of the box, the volume is going to be x times y times z. So it's a x, y, z, right? But we know that x, y, z satisfy this given equality. So I'm going to actually solve this equation for z, right? So I'm going to subtract 13x and subtract 10y, so that we're going to have 2z is equal to 30 minus 13x minus 10y. Right? Then I'm going to just divide through by 2. So divide by 2 to get z is equal to 15 minus 13 over 2x minus 5y. Right? So since we have expression for z, so I'm going to plug this guy in here, right? So that we don't have to deal with 3 variables. So this is going to be x times y, then z is 15 minus 13 over 2x minus 5y. Alright, so let's find the critical numbers, our critical points. Alright, so we're going to take the partial derivative of the volume V with respect to x. Alright, so in this case, y is just going to be a number. So I'm going to put y in front. So I already took care of this y right here. Alright, then to take the derivative, we have to use the product rule. So this guy, this is the first guy, times that second guy. Alright, so this is going to be, alright, partial of x would be, with respect to x is 1, times the second guy, so I just have to copy that. So it's a 15 minus 13 over 2x minus 5y plus. Alright, and it's going to be, let's say, first guy is x times the partial derivative of the second guy. So partial of 15 is 0, it's a constant, and negative 5y is going to be 0 too. Alright, so you're just going to get negative 13 over 2. Alright, so we have that. Alright, so let's clean this up. So y is already there, right? Alright, then we have, let's see, so number would be 15. So 15 is there. So 15. Alright, so 1 really doesn't do anything, so I'll just get rid of that. Alright, then we can combine x terms, so it's a negative 13 over 2x, and here's another negative 13 over 2x. So it's going to be negative 13x. Right? Alright, so it doesn't look good, so I'm going to rewrite that. So negative minus 13x. Alright, and the last term is negative 5y. So you have minus 5y. Alright, so we got that. Then we set this equal to 0. Right? So we got that. So these two, this equation gives you 2 possible conditions. So one is we either y is equal to 0, or we have 15 minus 13x minus 5y is equal to 0. So one of these has to satisfy, right? Then we can take the partial derivative with respect to y, right? So now, in this case, we know that x is just going to be a number, right? So I'm going to just to put x out here, right? Then we're going to take the partial derivative using a product rule. And this time, so pay attention to the purple here. So that's the first guy and that's the second guy, right? So if you take the partial with respect to y, you get 1. Multiplied by the second guy, again, it's exactly the same thing as before. So 15 minus 13 over 2x minus 5y, right? And a plus, right? First guy is y multiplied by partial derivative of the second guy with respect to y. Right? Partial derivative of 15 with respect to y is 0. Partial derivative of negative 13 over 2x with respect to y is 0, since it's a constant. Partial derivative of negative 5y with respect to y would be negative 5. Right, so we get that. Right, so this is going to be equal to, right, so again we have x sitting in front, so we just put x there. Right, then we have, this one doesn't do anything, so here you have 15. So this is just 15 sits here. And then we have an x term, which is minus 13 over 2, minus 13 over 2x. Right, the y term is negative 5y, and you have another negative 5y. So it's going to be negative 10y. Right, we have that. And we set that equal to 0. Right? So then we have, so we know that one of these has to hold. Either x is equal to 0 or 15 minus 13 over 2x minus 10y is equal to 0. All right, so let's look at a bunch of possibilities. And first, let's start with right, y equals 0. Right? Maybe I shouldn't circle that. Y equals 0. Right? So if, say, y is equal to 0, right, what are the possibilities? Right? Either we have x equals 0 or this equation equal to 0. So here, so x equals 0. Right? So if that's the case, one of the critical point is going to be 0, 0. So we got the first critical point there. All right, then we have, how about the other one? So our one equal to 0. So since y is already 0, so we plug y equals 0 here. So a negative 10 times 0. So that term actually goes away. So you have 15 minus 13 over 2x has to be equal to 0, right? So if you solve that, you can see that it's going to be, let's see, I'm going to put this guy on the other side. 15 is equal to 13 over 2x. And then I'm going to multiply both sides by 2 over 13. So it's x is equal to 30 over 13, right? So we get another critical point, which is x is 30 over 13, comma, y is 0, right? So we got the two critical points, right? The next one, what if the other one equal to 0? So what if, 15 minus 13x minus 5y equal to 0, right? Then again, we have two choices, right? Either x equals 0, or you have 15 minus 13 over 2x minus 10y is equal to 0, right? So let's look at the first case here.
But if x equal to 0, so we can just plug in 0 here. So you have a 15 minus, this is 0, so you have a 5y is equal to 0. Then you see that, let's see, we subtract 15, so you have a negative 5y is equal to negative 15, and then divide through by negative 5 to get the y equals 3. Right, so we got the second point. So in this case, x is 0 and y is 3, so 0, 3. Right, that's the third critical point. Alright, so this is the last case. So we have to look for the intersection between these two equations. Alright, so what I would do is I'm going to multiply this equation by 2. So we get 30 minus 13x minus 20y is equal to 0. Right? Then I'm going to subtract the first equation here. So you have a 15 minus 13x and minus 5y is equal to 0. So go through the subtraction here. Right? Then let's see. So 30 divided minus 15 is 15. Negative 13x minus negative 13 is 0. Negative 20y minus negative, so adding 5y, so it's going to be negative 15y is equal to 0. Right? So you can see that this is pretty clear. Y equals 1, right? So y equals 1. Right? So if you know that the y equals 1, you can plug it into any of these equations. So I'm going to just plug it into this one here. So you have, so from here, I plug in y equals 1, so it's a 15 minus 13x, and then plug in y equals 1, so it's going to be negative 5 is equal to 0. Right? So we can combine 15 and minus 5, so that's going to give us 10. Right? And a minus 13 x is equal to 0. Alright, so I'm going to just subtract 10. You get the negative 13x is equal to negative 10. Then I can just divide through by negative 13 to get x equals 10 over 13. Alright, so we got the last critical point. Right? So you have, let's say x is 10 over 13, and the y value was 1, comma 1. All right, so we have 4 of these, and it's actually, the first 3 is easy to find the volume. So at the 0, 0, x is 0, y is equal to 0, of course, the volume is going to be 0. Right? So this is not clearly what we're looking for. And here, if you're looking at, when y equals 0, so since it's y is already 0, so volume is actually 0 at that critical point as well. And when x is 0, of course, again, the volume is 0 too, right? So first 3 critical points actually gives you a 0 volume, which is clearly not the one we are looking for, because we want to maximize the volume of the box. So this is the last possibility. So this is going to be the one that gives us the maximum. So if you want to find the volume, so volume, and all you have to do is plug in 10 over 13 for x and 1 for y. Right? So what do we get? So x is 10 over 13, and y, so times y is 1. And then we have times 15 minus, right, 13 over 2 times, it's a 10 over 13, and minus 5 times 1, right? So we can simplify here. So 13 and 13 cancel out. 2 and 10 cancel out, so it's going to be 5. So we have 15 minus 5, so it's going to be 5. So it's going to be 5 times 10 over 13, so it's going to be 50 over 13, right? So the maximum volume is 50 over 13, right? So let's plug it in. All right, so the answer we got was 50 over 13. All right, let's check the answer. Submit for testing. All right, I came back and looks like we got the correct answer here. All right, that's it. I hope that this was clear.